So you're probably wondering why I have the 16th century painting in the background of a talk about computer vision. But there's a reason for this. So this painting was actually painted during a time of religious upheaval in Europe. And if you see this painting in an art gallery, you'll kind of get a sense that something's going on, something's not quite right. There's like a elongated skull on the bottom of the painting. But what you probably don't see right away is that this painting is full of symbols that is actually representing the political climate at the time. So you've got an upside down globe, you've got a lute with broken strings, you've got a math book open to division. And this painting is so rich with symbols that actually telling a story of what's actually happening during that time. And that's how I think about images. I see images as being a really rich source of data that's often quite underestimated. So when we look at imagery, we don't actually see the vast amounts of data that image actually contains. And I hope during this talk, I'm going to actually help you see how much images in property and places, all the rich data that these images can have. So I'm head of data science at Zoopla and HomeTrack. I'm also the founder of beautifulplaces.ai. So I'm going to take you through a journey of my commercial life as well as my side gig, Beautiful Places, which is my passion project for my PhD. So it's really great to talk about this project because I was actually right on the stage in 2017 when I was doing my PhD, and I was talking about how I was quantifying the connection between beautiful places and our well-being, and especially how I use computer vision to predict the beauty of places. So often when we go to a beautiful place, we get this sense where we just feel just so relaxed, and we just feel so much happier. So I wanted to understand if I can actually quantify the connection between the two, because it's something we intuitively feel, but without large-scale quantitative evidence, we wouldn't actually be able to convince governments, for example, that this is something important to focus on. So the data that I had to hand was very, it was tricky. So initially when I was looking at the data, I saw that there was data on things that are easy to measure. So there's, green space, distance to parks, land cover, measures of biodiversity. But it's very hard to find, data on the beauty of a place. And normally, when people, try to understand the beauty of a place, they'll go and conduct a survey. How beautiful do you think your neighborhood is? But this is good enough for if you want to do a local study, not really great if you actually want to go across an entire country, because that's actually quite costly and incredibly time-consuming. But luckily, these days, the internet is a fantastic source of data. So I was really excited to come across this website called Scenic-Or-Not, and it was created by Geograph for My Society. And it's this game that people play. They just rate these images between 1 and 10. And each image is actually representing a square kilometer of Great Britain. So by the time I came across this data, there was about 1.5 million votes for 217,000 images. So if we actually map this data, and if anybody's been to England, you'll see that the places that you like to go on holiday, like the Lake District, the Peak District, areas around the coast, the Somerset and Devon, are all coming out as being beautiful. And that's just by one image representing a square kilometer. So this really have a good signal here. But I want you to right now close your eyes just for 1 second and conjure up a beautiful scene in your mind. Okay, can you open your eyes? And most of you will have probably thought of a natural scene, maybe something like this, some beautiful meadow with some beautiful flowers, or a beautiful lake view. And normally when we think about beautiful environments, we usually think of them being natural environments. So this was going to be problematic for my PhD because I wanted to go beyond that. Because if I quantify the connection between natural environments and our well-being, I wouldn't be saying anything new to what people already have been understanding for a long time already. So I wanted to understand if there was a collective understanding of beauty that actually went beyond natural is beautiful. So there's a few theories on what makes things beautiful. One of them is Kellett and Wilson's biophilia hypothesis. So this is kind of explaining why the natural elements might come into our mind. And it's because they say that we have this innate connection to nature because certain natural elements have actually aided our survival. So, that's why we evolved to find, attractive, like climbable trees. And when we see them in a scenic view, we're going like, wow, that's really beautiful. There's also J. Appleton's prospect and refuge theory. And this one's interesting because it's kind of going beyond just what's natural. And he says that, you know, when you look at a scene and you can see far away and automatically you already feel relaxed. So again, that's conjuring up that feeling of safety because you could look into the faraway horizon. And he also says that places where you find refuge, like cozy places, are also places that, you know, we might also find beautiful. But those are just theories. So I wanted to see, can I actually see something in the data that I have? You know, what am I actually seeing that might support the understanding that what we find beautiful isn't just natural beauty? So this is when I use convolutional neural networks. So it's a type of deep learning algorithm that you apply to imagery to help me understand what's in, you know, I've got 217,000 images. I wanted to understand what's in those imagery. So I came across some research, and that's done by some researchers at MIT, and they were starting to understand, you know, when you take images of places, what do those images actually contain? And this was important to me because I didn't want to just use a standard object detection. I didn't care if there was a cat or a dog. What I really wanted to understand is characteristics that help me understand a place. So they had, you know, research about analyzed 2 million images around 21 cities in 3 different continents and started to extract different features like green space and architecture. So they went on to build MIT Places, and it's a really great algorithm for scene recognition. And using this algorithm, I can actually extract lots of different types of characteristics. So, you know, is it a coastal scene? Is it an office building, a tower? Is it a natural scene? Is it a man-made scene? Can you see to the, you know, faraway horizon? So a really fantastic resource for me to analyze what's actually contained in my images. And if we look at an example of that, you can see from the left to the right how it kind of judges. So on the left is like not so sure that a valley is in there, and on the right is saying I'm more likely to see a valley in there. Again, you see with grass, you know, not so much grass in there. Oh, okay, there's a higher probability there's grass in this image. And we can use that to kind of understand how likely a certain category is actually represented in the imagery itself. So then I did a statistical analysis to understand what are people rating as beautiful. So unsurprisingly, of course, we're going to see the natural elements. So we're going to see coastal scenes, valleys and mountains, and forests and trees. More surprisingly, and kind of music to my ears, we also see built-up characteristics as coming out as beautiful as well. So, you know, this is England, so of course we're going to see these characterful buildings like cottage represented here. We also see beautiful lighthouses as well. People are rating as more beautiful. And of course we see bridge-like structures like viaduct and aqueduct. I mean, probably most of us can actually pick a favorite bridge that we've seen. And then if we look at unscenic, it's not surprising again that we see industrial and highway. But I thought this was really interesting because it picked up on J. Appleton's prospect and refuge theory. So here, if you cannot see to the horizon, so areas where in the city might be feel a bit claustrophobic, people were actually rating that as being not as beautiful. And that was very interesting to me. But very surprisingly, people actually rated flat areas of grass as not being beautiful. And this is really interesting. So just because a scene is green doesn't mean it's actually beautiful. And it's very important for the green space debate because we always talk about, you know, we need more green space in our cities, but we don't really talk about the quality of that green space enough. So if it's just a flat area of grass, if it's missing, you know, beautiful trees, valley contours, it's not going to be a beautiful place for a lot of people to want to spend time in. So I told you, so the Scenic-Or-Not data is very rich, has about 217,000 images, but I only have 1 image per square kilometer. And this is a bit problematic because I actually really want to understand the connection between beautiful places and our well-being, especially in an urban environment. And 1 image per square kilometer is just not enough, right? There's so much variety happening within that square kilometer. So I needed to figure out what I could do. So I wanted to see if I could actually use convolutional neural networks that I used before to actually analyze my imagery, to use that instead to predict the beauty of outdoor images. And that way I could actually create more data on beauty, and then it'll give me a far richer data set on beauty in cities. So what I did was, and this was like in 2016 2016 when I started this. It was a long time ago. This is actually very easy to do right now. At the time, it wasn't that easy. But luckily, what I can do is I could actually transfer learn over the MIT Places convolutional neural network. And you can do a technique called transfer learning. So the reason you do that is because anytime you're training a neural network from scratch, to actually make it work well in imagery, you'll need millions and millions and millions of examples. However, if you do transfer learning, which means I use an existing network and just transfer it to do something subtly different, it'll actually work really well. I've seen it work even really well with even just 1,000 images. With something like beauty, it's so varied, so hundreds of thousands of images is good to have, which I had from Scenic-Or-Not. So I use that to actually train a neural network, or transfer learn, to then predict how beautiful an area is. So the same network used to predict the place categories from before, so it wasn't that much of a shift to figure out how beautiful is that scene that it's actually seeing. And it worked really well. So I gave it images of London. So this is from a website called Geograph, and it's a documentary website. And people submit images across all over the United Kingdom. I took all the images in London because even though I saw, my model accuracy looks really great, I also wanted to see, is it actually in line with my intuition? And because it's always good to just double check your results, even if the numbers look good. So I gave it, again, several thousand, hundreds of thousands of images from London. I started to see, can my neural network tell me where is it beautiful in London? So I gave it images of Hampstead Heath. And if you look at Hampstead Heath, so Hampstead Heath is a really beautiful park in North London. I spent a lot of my time there during lockdown when I just needed to get away from being indoors and just get some beautiful scenery in. And if you look at the dots here, the gray are not so scenic, green is scenic, and purple is very scenic. And all around Hampstead Heath, it's actually picked up that those images are actually a lot more beautiful than the streets around it. And if we look at one of the examples, that's Hampstead Heath Ponds, and it's a very beautiful scene. Then I gave it all the images, looked at central London, and we have little clusters of green dots, and those are all the parks that we're seeing actually as being beautiful. But I also noticed there's this path you can see on the left side, and initially I was wondering, what is that path? Is that a beautiful street? And turns out it's Regent's Canal. So again, here's a built-up area, a beautiful canal path that it's actually identified as being beautiful. So that was really interesting to see that. Now, remember before I said just because it's green doesn't mean it's beautiful. The same algorithm also picks up that if it's green, if it's next to a highway, if it's looking disheveled, this is not a beautiful scene. And then finally, going on with that built-up area, here's an area. This is where the Zoopla offices are. I walk by down the river and I look at this beautiful scenery, and it's picked up that there's a lot of beautiful built-up beauty in this area. And one of the scenes is, of course, the Tower of London, a very beautiful historic building, and it's picked it up as being beautiful. So it's really fascinating, all the variety that it's actually picked up. And you can see it here. If you look at the sample top 5% predicted images in London, you've got that beautiful, natural scenery, but you also have all these built-up elements that's coming out as beautiful as well. So, and here's the paper that got published, which, we showed that you can actually use convolutional neural networks to actually predict beauty as well. So it turns out that, beauty is not in the eye only of the human beholder, that an AI can also be trained to detect beauty as well. So this was this paper was published in 2017. And now I'm going to take you to the present as to what I'm doing now. So right now, I work in Houseful, and I'm head of data science for 2 different companies across Houseful, and that's Zoopla. So Zoopla is a property portal. So when estate agents want to list their properties, they list them through the Zoopla property portal, and people browse properties to rent and buy through that. And I'm also head of data science of HomeTrack, and that's where we do property valuations as well. So, for example, here's a Zoopla website, and one of the things you can do is you can check how much is your house could go for sale at the moment. And it's very addictive. You always want to know, especially in the current climate, has my house price gone up? Has it gone down? So this is something people constantly come back to. And this estimate is actually powered by HomeTrack, and that's where we create these automatic valuation models for most of the top lenders in the UK. And the way the automatic valuation models work, because we have to work with lenders, so there's two approaches we could do. We can either do a hedonic regression model, or we can do a comparables model. We choose a comparables model because explainability is key to our lenders. So the way a comparable model works is that you try to search other properties around your property that you're actually trying to estimate that are very similar in terms of metadata. Does it all, does it have 3 bedrooms? Does it have, is it a bungalow? Is it a flat? Is it a Victorian property and things like that? And what you're just trying to figure out with the data, the metadata that you have, like which properties are similar and how much did they get sold for recently. And you always weigh the most recent sale price more than, of course, the past sale price. So it gives you a pretty good way of estimating the value of a property. Of course, there's a lot that goes into it. We have a house price index, and it's a lot more other details that actually go into the final price of the model. But one thing, even though it does a really great job, the one thing we don't know, because we're using metadata, we don't know if the current property has actually changed. So one of the things we can't tell is if they have actually renovated the property or if they've added an extension. So I was trying to figure out, I've got this experience in computer vision. Is there something I can actually help to solve this problem? So luckily, because I'm also on the Zoopla side, we have all the data on the listings. So every year we have around 300 million listings, and there's average 14 images per listing. So that's a lot of data that we can get our hands on. So what I realized is that with all that data, we can actually use it to maybe detect the condition of the property. Because this is one critical thing, right? So if your neighbor's properties were in good condition, but yours has been neglected over time, it should not have the same property estimate as your neighbor's. So what we're doing in this model is we're actually taking the imagery, and we're also combining it with the property descriptions as well. Also, we're feeding in the metadata, so the year of the property is also very predictive of the condition. So we're triangulating all that information and then coming up with a final model that's a prediction of the condition of the final property. And our actual labels come from our surveyor reports. So across HomeTrack, we get actual surveyors tell us whether a property was in poor, good, or bad condition, and we can use that to actually have verified label data. So this gives us a fantastic way of actually creating a model. And so we use convolutional neural networks again, exactly the same technique I used back in 2017. It works really amazingly well, and we're able to actually predict the condition of our property. And here's an example of how it looks like. So on the left, it's saying it's 52% poor because I can't actually see, if the damage isn't as visible, but on the other side, it's 93% poor because you can actually see visible damage here. Again, we're using text as well, because sometimes, estate agents, they might want to show the property in its best light. So we also want to use little hints from the property, the text description as well. So, you have things like investment opportunity or no chain or profusion of potential. So what's really fantastic is if you combine the computer vision with, large language models, it can help you use those nuances to also figure out maybe something's up with this property. So we also tried 2 different versions. So we did BERT, large language model option, as well as logistic regression with TF-IDF, which is just to say, so one's a deep learning option, one's a very simple machine learning option as well. The thing is, the accuracy was largely the same. BERT, of course, did a little bit better, but because explainability was really important, we ended up deciding for the lender version, we want to stick with a simple model that we can have much more reliable explanatory explanations. That's right. So here are some examples of our explanations. So good, of course, will say stuff like, well presented, modern, new. And in poor, we've got that opportunity, potential. And really interestingly, we also see dining room. So when I saw the word dining room, initially I'm like, oh, that might be a correlation. So I really thought about it, and the dining room is actually very telling of the condition of a property. Because most properties these days no longer have dining rooms, because nobody likes to have a separate dining room from your kitchen. Most properties that have been refurbished will have combined their dining room with their kitchen or converted the dining room to something else. So if a property still has a dining room, that indicates that property has not been refurbished for several decades. So that's a good indication actually of the condition of the property, and you probably need to send a human surveyor to have a look. So where are we taking this model now? We also want to give reasons as to why we found that the property is in poor condition, because the reasons will kind of indicate, do we absolutely have to send a surveyor to see this property, or do we just have to kind of knock down the price in our estimate? So here, we're looking at actual damage. So we want to see if you could detect structural damage, broken roof tiles, damaged renders, faulty windows, because these are really serious things. A human has to go have a look at the property. But it could be stuff like it need of modernization. And it will be kind of a decision whether or not we do need to send a human, because this is not necessarily a bad thing. A lot of properties always need modernization. But it can actually give an indicator to the lender when they're actually looking at affordability. Well, this person's going to move in, they're going to have to refurbish the property, just want to make sure that they can actually afford to also refurbish the property to make it a livable place to live. So all really interesting data that we can actually provide our lenders with. Another thing that's really great for us is that a lot of our metadata isn't always correct. For some reason, anybody that works with data will know that there's no one source of reliable data. There's always mistakes in data for some reason or another. So having another way of verifying the property attributes actually help us a lot. So we can, look at the floor plans and actually double check that all our properties have the right, number of bedrooms and living rooms. Also because people might have extended it and changed it as well over time. And so we want to also verify, is there an extension? Because you can see in planning applications that they might have applied for an extension. We don't actually know if they actually did the extension in the end. And you're looking for other things that might be risky, like an outbuilding is something that's risky for a lender because, again, of the conditions. So it's something you definitely want to send a human surveyor to have a look. Some other things that are really interesting we can do in computer vision with our commercial products is for climate. Sorry, I'm a little bit asthmatic, and for some reason in Brisbane, my asthma is kind of going up a bit, so I'm a bit coughing right now. So a climate products that we have, so we can also want to detect, if there's solar panels, because that will help with energy efficiency. That's really important to understand when you're now lending in properties over time. You also want to understand about different climate risks, flood risks, for example. So right now, if you look at flood risk data, it's area level, but it's not property based. But if your property is on the first floor or ground floor versus the top floor, the actual damage to the property is really different. Also, if you have if it's actually been prepared, so this property you see on the right has moved up the door. So you can see that that property itself is more likely to be okay in a flood risk because it's built for that, rather than another property that actually hasn't had that into account. So there's so many different things we can actually look at by the images of property that help us with a wide variety of understanding about these properties. So what else do we use computer vision for in Zoopla? We also use it to understand consumer preferences. So for example, Airbnb, they use computer vision a lot, and they found that along with price and location, the photos of a property were the biggest influence in securing a booking. So we're also really interested in working with images as well to help consumers find what they really want. So one of the projects we're also doing in Zoopla is extracting lots of different tags across our property images. So poor conditions is one of them, but you also want to find lots of different things that consumers care about. Like, for example, you might really desperately want to buy a Victorian property. You might like, terrace properties. You might want sash windows. You might want a spacious living room or wooden floors or a place full of natural light. And that's all the things we can actually extract with imagery. And we can also extract this with the text as well. So again, as usual, we always, if possible, we always triangulate it by trying to find many different sources for the data that we're actually looking for. So here's kind of an understanding of the different types of property attributes we're looking for. So actual attributes, but also architectural styles, condition, property type, and location. So here's one example. We can actually look at the images, and there's going to be characteristics that tell us a bit about the style. So, Edwardian, Victorian, Georgian, new build is something we would be interested in. We can also look at the interiors of the properties and pick up different characteristics, like ornate cornicing, decorative tiling, and parquet flooring. These are like things, like sometimes people are obsessed, like especially parquet flooring. I would love to find a house with parquet flooring. So these are really interesting things to identify. The other thing that's also really interesting is to also look at views. So, we want to see, does the property have a garden view or a sea view? And this is also really interesting for our valuation side as well. Because again, if you're using comparable properties, and if you have one property that doesn't have a view, but the other property right next door has a better view, that property should be more expensive than the one next door. So being able to identify what the view is also really important. And finally, of course, we want to extract all these different attributes. For example, island kitchens, it's another thing that people are really desperate to get their hands on. I have an island kitchen, I love it. So we want to, if somebody's actually looking for a property, we want to make sure that they can find, the features they're really interested in finding. So when you're creating these computer vision models, especially when you're doing it for hundreds and hundreds of labels, is actually really a lot of work to get the labels right. And the modeling these days are actually really easy because everything's almost off the shelf. It's very easy to do, but the labeling is the most challenging bit. So we actually wanted to see if we can use ChatGPT to actually help us speed up the labeling. So what we did is, because we have the listing text, that was the easiest thing to do. You can also give the imagery as well right now. So we gave ChatGPT our property descriptions, and we asked it questions. So, is the property in need of modernization or updating, or is this a period property? And the trick we did is we didn't just ask it to say yes, no, or maybe. We asked it to say why. And actually asking why and actually asking ChatGPT to show in the text where it found the reasoning actually helped us increase the accuracy of the output, because it's like you're almost prompting ChatGPT to tell you the truth and not make something up. So that in itself helped. It was good enough for us to then, mass label like thousands and thousands and thousands of properties with the right labels we need. And you don't necessarily have to have a human verify it. And that's a really great way to start with the labeling of the model. Another thing that's really important to use is actually active learning. So again, it's a labeling that's the hardest part of training computer vision models. It's not the modeling itself. So one of the things you can do is you can already train your model, even if your labels aren't perfect, but you have something initial. So going back to our poor condition modeling, remember I said, so I've got surveyor reports from the past properties, and I have the property description, I have the property images, and I've got the surveyor report telling us whether it's poor or good or average. Now, for every property, I'll have about 10 images, but not every image shows the property in poor condition. Ideally, we would like to label all those images as being, poor, good, or medium, but that's a lot of work. So what you can do is you can not care about it because you have some initial indication from the surveyor data. You train your algorithm already with that data, and you use something called a query strategy, where you then start to look at where the model fails. So every time, say it's like a binary model, you're asking, is a property in poor condition? It's going to give you a probability score. And you can try to figure out, where did the model get it wrong, and actually focus on relabeling those parts. And that's kind of this way where you actually shortcut labeling hundreds and thousands of images. So here's an example. So again, we identify the images that are, that model was a little bit uncertain about. And then what you do is actually you use the image embedding. And again, a lot of tools have this built in when you're actually working with imagery. And you can find similar images. And that in itself can increase your training data for all the examples that your model is actually failing on. And using these techniques, you can get an image model working really, really fast. So it's always going to be your labeling. That's going to be the thing that's slowing you down. And you're always having to think about shortcuts to make your labeling faster. So getting started with computer vision. I just want to say that you don't have to be a data scientist to create computer vision models. And there are so many great ways to actually pick up computer vision right away. So we've got like deeplearning.ai. It's got fantastic courses on computer vision. You've got the practical deep learning from Fast AI. And the reason I'm saying this is because I just don't think companies use computer vision enough. And I would love to see developers just, starting to do computer vision themselves, because you don't have to be a data scientist to do that. And if you start experimenting with all the rich data that's in your imagery, imagine, what you can find out for your company. And again, the label data set, that's going to be your most difficult part, but there's a lot of tools that can help you get started. The first two are commercial options, so it's Labelbox and Encord, but they all have free trials. So you can always use a free trial when you're starting up your first computer vision project to see how it works for you. But Label Studio is a free open source version as well that you can also use for your computer vision modeling. And then some more tips. You always have imbalanced data sets. Say it's a binary model, you're very unlikely to get 50-50 split. That's not a problem. There's all these different techniques like oversampling and class weighting that'll help you deal with the imbalancedness, and that's not a problem. That'll already be built in to the computer vision modeling frameworks. One very important thing to watch out for is data leakage. I see this a lot with junior data scientists. They'll take a data set, and normally, with your machine learning data sets, you just have to do a split, right? 80% training, 20% testing, for example. One of my junior data scientists did that, so split the images for poor condition, like I'm going to do this and I'm going to split it 80-20, didn't think about the fact that he didn't look at the properties. So he had the properties mixed up between the train and the test. But of course, if you do that, you have data leakage. So whatever accuracy you have, you cannot trust. And that's the thing that happens a lot. Is like when you're working with images, you have to really make sure that if it's a part of the set, that the sets are actually separate. And I'm really surprised how many times people miss this. So I always ask everybody, when my data science is working, write down your methodology, because I want to double check that everything's been done above board and correctly. Another thing a tip is to, like I was talking earlier, is to let the model performance guide additional labeling you need. So you can start by labeling a random 500 images, or if you have an initial inkling of what the label is, just train on that. And start that, and then use that active learning approach I said previously to actually get your model going. And this is going to get you to production much faster. And of course, final tip is use ChatGPT to help you with your labeling, because that's going to speed up your process incredibly. Okay, so that's my commercial work. I'm going to bring you back to my research work I do as well. So this year, remember the research work I just introduced before about beautiful places? This year I actually created into a community interest company in the UK. And the idea about that is because it's my passion project, and I actually really want to find a way to bring more beauty into everyone's lives. So we intuitively grasp the profound influence of beautiful places. They enhance our personal joy, they solidify our community bonds, they act as catalysts for economic prosperity. But their quantifiable value still remains elusive. And so that's the plan with beautiful places, is that I want to bridge this gap with vital data to help people make more informed decisions about where we need to create more beauty. And I specifically created it as a community interest company. And so it's kind of an interesting model. So it's not a limited, it's not a charity, it's something in between in the UK, where all the profits go back to serve the needs of the community. So it's essentially a nonprofit. And the reason I did that is because that AI for public good element on this project is so critical for me. And I also want to ensure that the data is always protected. Because the data, again, we create by asking, it starts out with crowdsourced insights. So we ask people to rate how beautiful, they find their different neighborhoods through that one image. And then we use that data to train our algorithms. And I always wanted to keep that data, protected. So with the community interest company, the data is your kind of asset, is asset locked, and it always has to serve the interests of the community. So that's why I created it like that. And the first thing we're doing this year is we're creating a large-scale, high-resolution, beautiful places data for all the United Kingdom. Because it started out with my research back then, but I have the London data, but I want to create it for all over the country, and then I want to take it global as well. We use this data for research projects as well, because we want to understand the impact between beauty and our well-being. So this is a continuation of my PhD research. I don't do the research anymore, but we actually collaborate with other organizations to give them the data, and they can take it on to do their research. However, my business partner is still an academic, and he does some really interesting data where he's using these, the data to create generative models to understand what makes a place more beautiful. So before the kind of insights we were giving you, it's like natural areas, it's historical buildings, it's like, could be characterful buildings, it could be also bridge-like structures as well. But we want to take it to be more informed, and we really want to understand what it might mean for building new places. So some really interesting thing you could do is you could take a convolutional neural network, and you can kind of reverse engineer it or engineer it in a way where it actually produces something new. So you can ask it, like, can you create a more beautiful scene? And then you want to see what things it's actually adding now to that scene. And by analyzing that, you can start to understand what actually makes a scene more beautiful, but for an urban design perspective. So we want to see, is it more greenery? Is it like the lack of density or more density? Is it ornateness? And we want to give people an understanding of how we can create, buildings today or streets today. So this is kind of going into that a bit more. So that's what we'll do this year. So we're going to create this website. We're going to show the ratings for all around the United Kingdom. And then we're also going to give people an analysis. It's like, why is your neighborhood, more beautiful or less beautiful than somebody else? Again, we are going to collaborate with other like-minded institutions because we don't want to just keep the data for ourselves. So really interested in hearing about other institutions that could actually use our data. So for example, in the UK, we're collaborating with a walking app called Go Jauntly. And they have a community-based walking app where you can use it just for outdoor exploration. So we want to give them our beautiful places data to create beautiful walks that anybody can access, and for it to be like free of charge. So you want to refresh yourselves, you want to go for a walk, but give me the beautiful walk in the city so I can feel better. And finally, someday in the very future, we also will create our own apps as well. So envision an app just guiding you to a nearby scenic location. Or picture yourself immersing yourselves in breathtaking landscapes in your own home. So, we can say, you're tired, you just want to see that beautiful scenery personalized to you that's going to uplift you. Imagine you can project that into your wall and suddenly feel more relaxed. Or imagine a day in the future where we can use augmented reality to actually recreate a beautiful scene as you're walking down a street that's not that nice to look at. So again, you're walking to work, you want to lift your spirits. Can we just create some beauty around you to kind of help enhance your mood? So there's so many things we can do with this data that could be so interesting for our well-being. So ultimate vision is to actually ensure everyone can access and appreciate beauty regardless of where they are. So I really want to bring beautiful places to Australia. So if anybody's interested in helping me bring it here, again, just come and talk to me. We're happy to try to figure things out because I don't want it to just be something that's based in the United Kingdom. I want it to be in Australia as well. It's such a beautiful country, very beautiful cities, and I would love to kind of create the data in Australia as well. So it'll be fantastic to try to figure out how to make that happen. And that's it. So thank you. Happy to answer any questions about beautiful places. My work at Zoopla and Home Track. Covered a lot of ground here. But thanks.
Thank you.